Going on now to continue our review for the final exam. We're looking at, again, vocabulary check. Helps you communicate, and many of the main points of mastery are involved in knowing the vocabulary. Chapter 2 deals with equations, and we'll want to know these. For instance, like terms, equivalent equations, linear equations in one variable. Linear, by the way, you may recall the exponents are just to the first power. Numerical coefficient, a formula. Unlike terms, linear inequality in one variable. A compound inequality. All real numbers. No solution. Reversed. The same. Now, as I read these over, I can see that I already have an idea what these are, and again, it's matching them up. So let's take a look. Terms with the same variable or variables raised to exactly the same powers are called like terms. And I think we should put like a little line here to indicate that we use that. Okay. If terms are not like terms, they are, well, unlike terms. What can be written in the form ax plus b equals c? All right, this is the standard form for the linear equation here. There it is right here. Linear equation in one variable. What can be written in the form of this, where we have one of the inequalities and perhaps one of the other three? Well, this would be a linear inequality in one variable. Again, the difference is this is an equation with the equal sign, and with the inequality sign, it's an inequality. But notice the variable x is just to the first power. That's why it's linear. Inequalities containing two inequality symbols are called compound inequalities. An equation that describes a known relationship among quantities is called, I guess, equivalent equations. Okay, we may have to fiddle with that if that's used somewhere else. All right, the what of a term is its numerical factor. Well, that's a numerical coefficient. equations that have the same solution are called and I see I have to do a little adjustment here. This one, equations that have the same solution are called, this one is equivalent equations. And this one up here, an equation that describes a known relationship among quantities, I believe that is a formula. Okay. So again, use pencil if you're writing these out so that you get a little bit of practice, and keep in mind, you got to match them up. Okay. Number 9, the solution to the equation x plus 5 is all real numbers, because these are identities, and the solution to identities is all real numbers. Now here, when we solve number 10, if we were to subtract an x from this side and an x from this side, we'd have 5 equals 4. Is that a solution or a true statement? No. So in that case, it's no solution. Number 11, if both sides of an inequality are multiplied or divided by the same positive number, the direction of the inequality symbol is the same. That is, we don't change the direction. But, as you see in number 12, if you're going to multiply or divide by a negative number, then we have to reverse the direction of the inequality. Okay, well, again, I have the answer key somewhere, but I was doing these as if I were a student and looking them over and checking them out. Let's go on. We're now going to do the chapter highlights here, as we did in chapter 1. Okay, looking over simplifying algebraic expressions, we talk about the numerical coefficient of a term is its numerical factor. So in negative 7y, the coefficient is negative 7. If there doesn't appear to be one, as in the x here, it's actually a 1x. And then here it's 1/5. Okay, like terms have exactly the same variable and exponents. Both of these variables are x to the first power, and this is xy. And even though they're sometimes written in a different order, they're still the same variables. So these are like terms, while these are unlike terms. When we combine like terms, we just add or subtract the numerical coefficients. We said a technique for this is to put them in vertical columns of like terms, being careful of the signs. And to remove parentheses, we just multiply through. If there's just a negative in front, we would reverse all of the signs that are within the parenthesis. All right, going on to the next part here. A linear equation in one variable. There's standard form, and there's the typical linear equations. Equivalent equations are once we start with something, we're going to add 7, its additive inverse, to both sides. Here it becomes a 0. Here it becomes 17. These are equivalent equations, and since you only have an x on one side and a number on the other, this is the solution. And the steps we use to solve an equation are called solving an equation. That is, the logical sequential steps to take various terms and get all of the numbers on one side and eventually just the letter on the other. And we have various skills. Here we're using the addition property. Here we're using the multiplicative property of the reciprocal to get the a all by itself, a 1a. And notice we could cross cancel there. 2 will go into 18 twice. 3 times 9 is, I should say 2 will go into 18 9 times. 3 times 9 is 27. Okay. And here they're showing you in great detail. I'm not going to go through all these steps, but if you looked at our previous videos, you saw that we had these steps basically. Step 1, remove fractions by multiplying each of the terms by the common denominator. Here it's 6, so we're multiplying everything by 6. The 6's then cancel out to some degree. We get rid of the fractions, then we get rid of the grouping symbols, we combine like terms, we transpose, and eventually we divide by the numerical coefficient of the variable, and that gives us a solution. And you would check if that solution is true by putting it into the original equation and seeing if you end up with a true statement. So when we have word problems, again, we want to read it and reread it. We want to translate the English into an algebraic equation, solve it, and then we interpret our results. When we did problems involving formulas, again, these are equations that describe known relationships among quantities. Here is the formula for area of a rectangle, simple interest, perimeter, whatever. You would substitute values to find the missing letter, or in some cases they just want you to find the letter. Here they want you to solve for L. So the first thing is you transpose the 2L, or I should say the 2W, to the other side. It changes its sign. Then you divide both sides by the numerical coefficient of the L, and you end up with a solution. Now, when we deal with percent and mixture problems, I had stressed, and hopefully you've picked up on this, is to convert this to an equation. So with that in mind, let's do one here. It's all written out below, but we can do it here. So 32%, that would be 0.32 of indicates multiplication of what number, we can use the letter n, is an equal sign, and then 36.8. So to solve for n then, we're just going to divide both sides by 0.32. And since you can use your calculator, that works out very well here. So we had a little phone call there, and again, these will then cancel out, and we do the division, and we get x equals 115. So the concept of using an equation that fits in with the earlier sections is a very good idea, I think. Okay, let's go on. Now, another one that's very common is to deal with the mixture problems. I guess we'll look at this a little more closely here, where we have a 20% acid solution, and we're wondering how many liters of this must be mixed with a 50% to obtain 12 liters altogether of a 30%. Well, this is a case where, again, if you watched an earlier video, we said when you have something, I suggest you make a little box, and this box will represent 12 liters. Well, how do I divide that 12 liters into two parts? Well, part of it will be, let's say, x. And then the other part is going to be 12 minus x. So if I added these two together, I get 12. The x's just cancel out. But I'm going to say let this be the 20% and let this be the 50%. So it's going to be a combination of this part plus this part here. There's a 12 there. And we have it all nicely laid out in this chart here. So there's the 20%, and this is the amount. That's the strength. And then the other part is 12 minus x, as we did in our little chart here. And that's 50%. So you would indicate that as 0.20x, and this is 0.50 times this. Has to be in parentheses. So we distribute that. And you're going to make eventually 12, which is 30%. So to translate it, there's the first part, plus this will equal that. And as you do it, you will find out what x is. And as they are showing here, x is going to be 8. So if x is 8, what is the other part? Well, you subtract the 8 from the 12, and you get 4. So your answer statement is you will need 8 liters of the 20% and 4 of the 50% to end up with a mixture of 30%. Very, very, very typical of what it is. And it wouldn't take too long to make a little chart like this if that's what you have on your final exam. All right, let's go on. I think we're about ready to wind this up here. All right, here's another word problem that they're giving us. Here it's a collection of dimes and quarters which have a total value of this. And there are 3 times as many quarters as dimes. Find the number of quarters. And I remembered, again, if you looked at the video on this word problem section, I did a lot of these in great detail. So here we have, let's see now, here's our total value. In fact, this could be done in two variables very well, but here we're just using one variable. So it says let x equal the number of dimes, and you have 3 times as many quarters, so that's going to be the number of quarters. So how much is a dime worth? Well, 10 cents times the number of dimes. 25 cents times the number of quarters, which is 3x, and that's your total value. Now when you finish, you end up with x equals, well, this is going to be your number of dimes. So how many quarters do you have? Well, 3 times that, so that will be 69. And there they are. Okay, moving on now to the last part of Chapter 2. And I see we're running over 20 minutes here. We're going on to inequalities. And when we do inequalities, remember there's a whole range of answers. So often after we solve it using the techniques of an equation, keeping in mind the only thing different is if we have to multiply or divide by a negative, we have to reverse the inequality sign. And when we get an answer, again, if it's an inequality and equal, we're going to use a bracket. And if it's less, we face it to the left. And in interval notation, this is coming from negative infinity going up to negative 5. And I see they made an error here. They can make errors too. This should have been a bracket here, not a parenthesis, because they had the bracket here correctly. Okay. And then here, again, don't have to change anything. And it's just an inequality sign greater than, so that's when they use a parenthesis. And it's going to positive infinity. And here, when you had to divide by a negative 2, both sides, they're changing the direction of our inequality. And since it also contains an equal sign, they're using a bracket, and that is correct here. Okay, let's see what else they have. And here they're just giving us more of an equation, or we have to get rid of our parentheses, and things are just about the same. Now this is a compound inequality where you have a variable in the middle, and we're just solving it. And again, it'll be depending upon what sign is there. This is only an inequality, it'll be a parenthesis. Only an inequality, a parenthesis. And interval notation is just that. Looks almost like an ordered pair, but remember, these are answer solutions in interval notation. And that looks like about it. Then they're going to give us some examples, so we'll wind this up.